Okay, this animation is about fractional distillation, a process used to separate crude oil into the many different individual molecules it is made up of. Now, why do we need to do this? Well, crude oil is a mixture of hydrocarbons that can be burned, releasing energy which we can use in a variety of ways. But this mixture has too many long hydrocarbons in it that do not burn so easily. It also has many impurities. So the best way to harness the energy from crude oil is to split it out, separate it, into groups of similar hydrocarbons, particularly short ones that burn more easily. This process takes place in a fractionating column, one of the tall cylinders in the photo here. A fractionating column is also called a distillation column. Distillation is a means of separating out this mixture of different substances by boiling them and then condensing them at different positions up the column. Hydrocarbons of very similar sizes condense at a similar temperature and are collected as a smaller mixture. These groups of similar hydrocarbons are called fractions. The process begins by piping the crude oil into the furnace, where it quickly heats up. Here, the hydrocarbons with the lowest boiling points are the first to become gaseous and enter the column. Now, appreciate why the smallest hydrocarbons, those with just a few carbon atoms, are collected at the top of the column. It's because only at the top of the column is the temperature low enough for these small hydrocarbons to condense, to turn from gases back to liquids again. So, very small hydrocarbons have low boiling points and are not viscous. They are very fluid. So, which are the first fractions to be collected here at the top of the column? They are methane and liquefied petroleum gas, LPG. Then, two groups of slightly larger fractions are collected a bit further down the column. These are used as fuels for cars and for airplanes. Further down, even larger fractions are condensing at just below their boiling points, which of course are higher than the boiling points of the fractions collected above. Finally, at the bottom, very large, thick and treacly hydrocarbons, such as heavy fuel oils, are collected. So, very large hydrocarbons have high boiling points and are viscous. They are thick and not very fluid. Okay, a quick recap. Now, I just want to clarify a couple of definitions here. First, the definition of crude oil as a mixture. In a mixture, many different compounds are found together, but they are not chemically joined. They're not bonded together. This is why fractional distillation actually works. As we've seen, the different substances boil off, become gases, at their respective boiling points. The second definition I think you need to be very clear on is the word volatile. Sometimes this word seems to suggest violence or explosiveness, for example when we talk about a volatile personality. Well, in the science of chemistry, be clear that volatile very specifically means easily turns into a gas.